Let's see what Advent of Code 2025 is prepared for us for the second day. Today we will be dealing with a gift shop, and this gift shop has some product IDs by which they identify the products that they sell, and there are some invalid ones. And the invalid ones are look like that their ID contains the same number twice in a row. It's basically just repeating the same subsequence of numbers multiple times. So basically here we have 64, 64, and 1, 2, 3, 1, 2, 3, and so on. So these are invalid IDs when it contains two sequences of numbers in a row which are equal to each other. So what we are supposed to do is to, for a given set of numbers, for a given range of numbers, to calculate what is the right number of sequences that are invalid in that range. So that's what we will be going to do today. So I will get this sample input, against which we will try to build our first solution. And you can see that it's just a list of the sequences divided by comma, but it's a single long line, so I will just break it down to a single long line for simplicity. Good. So this is what we have, and now what we will try to implement the solution to this first part. So we will get the line. Let's turn off these. Okay, so we will get the line. So I will get async, and now I will split it. I will split the line, split it by commas. So now we'll get the individual lines, and for each part in parts, this is going to be the range that we are working against, and the total number is all the invalid IDs. So yeah, so I will have something like private and count invalid IDs with the given range. So let's do ulong lower bound, ulong upper bound, and let's close it like this. So I will first parse these. So I'll do bounds, and first lower bound will be ulong parse, upper bound will parse, and invalid count, and I will add it to some total 0, and I will add it to that. So plus equals equal invalid count, and finally when we're done, we'll just return total string. So that's this thing, and now we will try to calculate the number of invalid IDs. So for even length, this is basically us breaking down the number in half and checking if we can do 1, 1, then 2, 2, 3, 3, and so on. And once we hit the upper limit, then we can stop. So we will be trying all the possible combinations. And for this one, it's basically first trying to break it down as a even number here, and then we will end up with 100, and that's it's odd number of digits, so it cannot be broken down into two parts equally. Here we will just break it down to 2, and again continue from 10, 10. So that's the one that we will get, and so on. So that seems reasonable. Now, how do we figure out how many of them are going to be there? So I can break it down to 2 parts, take the first part, and then try all the possible options that I have until I reach the maximum. But how do I get the maximum number? So basically, what I could do. What I could do is get the first half if it's an even number, and if it's not an even number, even length number, then I can get as if it was 0, 9 or something like that. And then try all the possible options. So, yes, that sounds pretty good. So what I can do is I can take the starting number, or I can take the lower bound, like number as string, so lower bound to string, and if the length, if length is modulo 2 is not equal to 0, we will just extend it on the left by 0. So we will add a 0 at the beginning. And now what we will do is we can take the first half. So we'll get the first half like this. Basically, that's exactly what we need. And then we will parse it like that. And then what I can do is basically go while true. And generate a number that will be so basically what I can do is so I can combine that to so I can do a full number will be first half plus first half. So what I mean with first half number to string, like current number. What I can do actually is do current number, and then I can do just while true full number will be current number to string plus current number to string, so twice the same number, and I can parse it, and if full number as long is greater than lower bound, or equal to lower bound, and it is full number or as long is less than upper bound, I can add an invalid ID. So our count is 0, and I will be adding to that number here. And in the end, I always do. So if it's bigger than upper bound, we will just return because we are done, because we overstepped the upper bound. But if it's not, then we will just return current number. We'll just go with current number plus plus, and we should be getting the correct number of results here. We'll see what happens. And maybe I missed something here, but it seems pretty reasonable so far. It is not definitely the most efficient way, but it should be working at least. So it's 8 here. 2, 3, 4, 5, 6, 7, 8. 8. That's the number of them is right, but I need to sum them along. So let's do some invalid IDs. I will do ulong, and I will do total and plus equal invalid sum, just to rewrite it here. So I can do something like this and count, return count, and I will do plus equals full number as ulong, and we should be good here. Although it's, I'm doing ul here. Good. Let's see what happens. The number is again ulong. So this is as we expect it to be. So what I will do is unload the actual input. So like that, and I will pick the input file here. Let's see. This is the input file, and that's the result. Okay, so that's a correct result. And let's see what happens with the second part. Okay, so in the second part, we are supposed to check for even more repetitions. So originally it was just 2 times, but we can do 3 times the repetition, or 4 times the 5 times the repetition, and so on. So like multiple subs, even shorter substrings are valid. So what we can do is not just break it down in half, but also like in fourth, like we can start with half because that's the minimum possible size that we can cover. Although it has to be minimum size of the second number, kind of, because that one decides was the length, the minimum length that we can, the maximum length that we can cover. And then we can go from there and add up the numbers as we go. Let's see what happens. It's a little bit murky to understand how to adjust this, but it should be possible. So from the lower bound to the upper bound, and we will start with we'll do it for any length. So we'll start with for var length equals 1 to length upper bound to string length plus plus. So for each of the lengths, we will try to calculate the options that we have. So we'll take we can actually start with 0, and we can continue and increase the number as we go. So we can start with 0, rather 1, yeah. So we can do what we can do is current number. So the check will be if you're greater than upper bound, yes, but also, so we continue in that case. Yes, so for partitions with 0, 1 to at most the length, the upper bound length divided by length to string. So we'll repeat the number and a given number of times. So for each number that we have, we will try to repeat it multiple different times. And that number let's see. And actually, we need to do this differently. Would be a lot of repetition. So we can cut it down in the middle. Then fourth. Actually, it seems that the ranges are not that huge. Because the ranges are not that huge, we could be checking each of the numbers and just checking if they have the repeating sequences. That might be even faster. So what I can do is do 4 like this, and then do check if it contains if it's invalid. So if is invalid current number, if it's invalid, then we will add it to a total. So long sum will be 0, and we will add it to that sum. So sum equals so like this. And now to check if it's invalid, so it will be is invalid current number. It's gonna be by doing number as string. And now for length, subsequence length equals 1, subsequence length less than number as string length divided by 2. So what we do is we will be checking that it contains repetition of the same subsequence. So we'll do the first subsequence. Yes, first subsequence. We'll get the substring. Then we will repeat it. Subsequence, and then we have this very useful repeat that will concatenate, and then we will concatenate those repetitions of that subsequence, and we will not repeat it this time. Okay, so we can repeat it. The number of repetitions will be number as string length divided by subsequence length. So we need to repeat it a given number of times, and we will check if it's the same thing. And if it's the same thing, we will return true, and we will return false if it's not. And that should be it, hopefully. Let's see if I can test it against the test data. So this will give us the number, then finally we'll return the sum, and we should be getting the total there. So 17, okay, so it seems okay. So I can try it with the test data. So the test data will be this. And this is the result. And that is right. Okay, so we have the second part solved as well. And we have finished day 2 of Advent of Code. I will see you tomorrow.